ask the question.
Sounds
So
like a
have
very
fun.
good plan. Thank you very much, and thank you all for coming, and thank you all for joining. It's really it's like coming to Romania. I really love doing that. I've been doing it quite a few times, but last couple of years, for some kind of obvious reasons, we couldn't do that, and that is a bit, well, a little bit too sad, really. I have to say that. So, I'm happy to be able to be here at least in virtually. So today, I would like to. I mean, I would like to share some of my experiences and um, some of the things that I work with, because, well, a few words about myself. My name is Rustam. I work for a consultancy company called Computas. We have an office in Romania. That's one of the reasons. I mean, there's usually two reasons for me being a lot in Romania. It's usually work or walks days, Bucharest, that they usually that usually brings me to Romania. So I work for a consultancy company, and I work a lot with clouds. I work a lot with Java. So I'm a Java champion. I'm also a Google developer expert for cloud. So those kind of things I usually see a lot in one way or another. So I thought that maybe I should try to put them together and give some people some tips and tricks and ideas about what typical those cloud native applications that people talk about are and how you can build those. So before we get started, or before we get into the actually topic itself, I would kind of like to start with this a little bit. I mean, you can call it a disclaimer, right? So it's you've seen this kind of sticker before, in the form of stickers, posters, whatever, basically saying there is no cloud, it's just somebody else's computer, and that's what it really is, right? It's just somebody else's computer, so you don't have to manage the hardware and stuff on it. But that computer brings a few really nice things for you, because it's a bit more than just bare hardware. It has some things on top of it, and it gives you some abilities, extra abilities that you typically wouldn't have in your own environment. So let's see how you can utilize those, and how you can build applications that can benefit from those things that I mentioned. And the next thing I usually do is to give you a definition of what actually cloud native is, and that's the definition by CNCF, so Cloud Native Foundation, that actually um, uh, you know. Uh, runs the whole thing and has a lot of like an umbrella over a lot of technologies that uh, call themselves cloud native. And this is something that you're never ever supposed to do at a presentation, is to actually give people like a wall of text and just hit them with this huge wall of text. And probably you're way into the reading that text right now, you're kind of way into the a paragraph or two. And just to stop you from doing that and distract you a little bit, I'll and help you a little bit. Actually, that's the kind of the main purpose of that, is to give you an idea, to show you the main words, to kind of highlight the keywords here, and to help you a bit even further, I remove all the other words. So now we're left with some important keywords from the definition, right? So what is that? Well, it's scalable applications. It has to do, or should be able to run in public, private, or hybrid clouds. It contains containers, so it's made of containers. It has most likely to utilize service meshes, microservices. It has immutable infrastructure, declarative APIs, and also it's like loosely coupled, resilient, manageable, and so on, so on, so on, and a lot of things about automation and frequent change and all that, right? So to help you a little bit, even a bit more, to help a bit further, is I kind of try to split it up in three main parts. So what are we building, how we're going to build it, and why on earth should we actually do that. And now we can go to a little bit different topic than cloud native applications, and a bit more into the idea of how do you convince others to do things, or to to buy things or to say yes to things and so on. And usually you start, the typical thing is that you kind of use this little drawing that I have on the side there is just, usually you would start with why. So why should you do that? It's not just like do this because blah, blah, blah. Usually explain why people should do that. Then you go a bit into how they should do that. And then you tell them like what kind of benefits and what things will what they should do really, right? So technically you should read this definition kind of from the bottom up, right? You go with why, how, and then you actually talk about what. Because like if you think if I come to you and say, you know what, now you should build scalable applications because so they're able to run on public clouds, and then you would be like, okay, fine, I yeah, I okay, but why? And that's kind of the first thing you do. Or when you try to explain something to a like 2 year old, right? You don't do this. Why? You know. So let's start with this why part. And why part in this kind of context is typically, at least in my book, the way I try to categorize it is those five things that very often are business needs, because business needs, they are kind of the needs of the modern business. So nowadays, as opposed to, I don't know, 15, 20 years back when we were still doing a lot of like waterfall-ish kind of way of developing things and all those kind of things, now we need to do things in a different way. Now companies need this speed, so time to market as fast as possible. um, and to do that, you need to be able to have applications that are able to do that. So you can actually develop your applications fast. You should be able to deploy applications fast, and so on, so on, so on, right? So, and this kind of things we see all the time. There are competitors, like two different competing companies that would come out, and the ones that actually push their concept, their software to the market first, take the biggest share of the market. They usually tend to have at least an advantage, if not just winning the whole thing, but they would have at least some kind of advantage of this, right? Um, so that's one thing, right? And then the second thing is kind of connected to the speed and time to market and all of that, but it is also about how agile is your application. I'm not talking about agile as software development thing. So, I mean, if you're doing Scrum, Kanban, whatever, it doesn't matter. I'm not talking about this right now. I'm talking about how your application is able to react to change. So how it will adapt to change, how it will, how, for example, say you want to deploy a new version of your application. How easy is it for your application to make this version 2.0 or 3.0 or something available without too much downtime? That's kind of thing I put typically into this agility concept that I called. Um, so like, rolling updates or like red green deployments, all those kind of things, I would kind of typically put as a way of solving this agility problem. The third thing is reliability. So now we're talking a bit more about how your application would behave um, to those changes. So uh, I want my application to be there when I need it. I want it to be there no matter how many users it has, no matter how where those users are in the world. I want to have the uptime, the SLOs and all those things, and my customers obviously happy because of the uptime that is, I don't know, say 98% or whatever. It doesn't really matter what you set as the objective, but the point is that it should be reliable. It should be there when you expect it to be, right? Um, and at here we're talking about things like availability. We're talking about things like scalability. So how does it scale? And if it is if it has enough automation, so you can actually do things in a very reliable manner and actually reproducible manner. So um, it will be same results every time you do something. And again, this is just business needs. We'll talk about ways to solve that in a bit, but I just kind of giving you the typical needs of a business, typically what usually customers would ask. And the other thing would be they would be asking, which is again connected to reliability, is resilience. And resilience is typically a little bit different animal. It's a bit more about the thing that I mentioned earlier, where you have a different kind of pressure to your applications, right? It can be users, the ones that this kind of scenario that I mentioned a few minutes earlier, where you have maybe 1 or 10 users in one location, or then you have hundreds of thousands of users overnight because your application got super popular and very, very, very demanded. You get like hundreds and millions of users uh, across the world. And how do you do that? How do you make sure that your response times are actually still decent and your uptime is still there and your application doesn't go belly up just because the amount of users increased drastically, right? Um, so it with this we need to do a few things, right? We need to also address fault tolerance. So if something else goes down, something breaks somewhere, maybe out even most likely even out of your control. But if it's something breaks, what do you do? What your application does? Would it just crawl up in a corner and die and just like throw out 500 errors to everyone who tries to look at it? Or will it actually graciously kind of say, you know what, you can do these functions, but these functions are not available because something broke and we're working on it. Just stay put for a little bit. We'll be back, and everybody's going to be happy from like, when everything is up and everything, right? So all of that is a ways of like attacking the resilience part. And the last thing is that usually customers and businesses would mention is this thing of avoiding lock-in. And this is a bit kind of slightly misunderstood concept from time to time in my experience. I mean, people sometimes take it very literally. So they say that, oh, well, you know what, if we're going to develop something on a cloud A, then we cannot use the kind of the managed services provided by Cloud A because then at some day we will not be able immediately migrate to Cloud B. But then you would be like, yeah, but this is not what it is about. This is not about just like moving your virtual machines and putting it on something else. Yes, of course you can do that, but then it will cost you more and it will probably have a lot of issues with performance and stuff like that because managed services might be actually uh, really nice to utilize. So what I would say is that avoiding lock-in means for me quite often is that if it is a standardized kind of software, even though it's managed, so if it is a managed Postgres or MySQL instance, I know that I can most likely port it with minimal efforts to another managed or even non-managed, just like on-prem Postgres or MySQL instance, and it most likely will work without any trouble. But then I still will get all the benefits of it being managed and everything. So lock-in is not necessarily just putting everything in VMs and just running it as if you would be like on a specific computer, but think about that. And if you hear your customers or your management or whoever talks about this kind of thing, so it might be a good idea to keep that in mind. Um, so that is the why part, right? So now let's talk a little bit more about um, the what, right? So, I mean, we've seen in the definition from CNCF, there was this talk about scalable applications. We'll talk about what scalable applications actually mean in a second, but it was talking about scalable applications and that they're able to run on different kinds of clouds. So now I would like to talk a little bit about this kind of different types of clouds. So um, first thing I would like to say is that it does not have to be cloud. So cloud native does not mean that you have to put it on clouds and that's it. It can be, and it probably possibly should be also be able to run locally in your on-prem environments as well. And all of those things that I'm going to be mentioning here, you don't have to necessarily implement them in exact order that I give you, and not you do not need to do all of them at the same time. You can actually do them tiny little bit at a time, and by incrementally making it a little bit and a little bit and a little bit better every time, you will still achieve the goal. You don't have to do that all at the same time. So, like I said, it doesn't have to run in cloud, but typically when we talk about clouds, that would be um, um, I'm just trying to follow on the comments and see if there are some questions. So yeah, first of all, public clouds, right? It can be a public or private cloud on your on-prem, or it can be public cloud by typical, the main 4 or 5 providers out there that are kind of the mainstream ones, and then there's a bunch of other ones as well. It can be multi-cloud, and multi-cloud is an interesting thing. Multi-cloud is typically where you have different providers, but you utilize those different clouds at the same time. The reasons for that can be quite different. So it can be something like some of the offerings in on one cloud are cheaper than on the other cloud. So you might want to use some things like, say, I don't know. For example, you want to use machine learning on cloud A, and you want to do the virtual machines or your apps or your databases on cloud B, and something else in cloud C. That would be typically multi-cloud thing. Sometimes people use multi-cloud also as a way of for a very kind of critical uptime critical applications, they would also be interested to run it on different cloud providers. So if one provider goes down for some kind of reason, then you have a failover running on the different cloud, on different infrastructure, and different networks, and all the other things. So your application is still up and running and things like that. So that might be a reason as well. Might be also some kind of hardware things and so on, so on, so on. But the point is that you are actually able to run parts of your application on one cloud and some other parts on the other, and then you kind of make them talk to each other. And the last one, which is a bit different from multi-cloud, is a hybrid cloud. And hybrid cloud is um, kind of almost the same as multi-cloud, but then now you have your on-prem solution and the cloud. So you don't have 2 clouds, but one cloud and one on-prem solution. Um, so yeah, that is those 3 things that we need to keep in mind. So when we talk about cloud, this can be all one of those 3, but it can also be none as well. So it can be just your on-prem solution, so only the racks on in your basement or wherever you keep your servers. So now let's talk a little bit about the actual 5 tips and 5 things to address all those business needs and to make sure that your application is actually being able to run on that. And like I said, I mean, I'm trying to keep here it independent from the cloud technology. I'm trying to keep it independent from the platform. So, but again, my main uh, area of expertise is Java. So I would be, if I will be using any examples, I will be probably kind of leaning towards Java, but you can do this. Doesn't matter really what platform you're running your stuff in. So first thing first is kind of the obvious thing that people talked a lot about during the last quite a few years now is one way or another achieving this loose coupling thing. And usually the way you do that is to separating things into microservices. And there has been millions and millions and millions talks about like splitting up the monolith and all these things and everything. But the point is, it doesn't really have to be. You don't have to split your monolith into microservices to say, oh, well, we're loose coupled. Yes, that's correct. But the thing is, you can do it gradually. You can move parts of it, or you can start just by modularizing your monolith and putting in different modules and start there, and then actually start moving it to a module. So, like for example, maybe even using the Java module system to build them separately, and then kind of move it gradually into microservices and stuff like that. Because if you have a several 100,000 line of code, it will not happen overnight that you will be able to actually go to microservices, right? Um, And so then you need to think about like first, can I put it in microservices? Well, maybe not, but can I do something before that? So can I actually think about architecture of my applications? Can I make sure that they are actually are I can work towards this loose coupling thing. And the other thing would be nice to think about is APIs. So maybe you need to define APIs, and maybe you need to kind of make it a bit more formalized so you can actually make sure that your applications can talk through like specific APIs, so then it will be easier for you to split them into microservices and stuff like that later as well, right? And if you've done all this microservice fun things, then you'll probably need to, because I mean, it's not only just walk in the park. It's actually a lot of work splitting up. And then when you split it up, you you'll need to make sure that they are able to talk to each other, that they are using the right permissions to talk to each other, they are actually being like they can see each other, and some other services that are not supposed to see each other, they're not. So there is a lot of things that you need to think about it, like when you split things up in tiny little uh, independent boxes, right? And that's where the service mesh part comes in. So you need to think about like as your architecture as building blocks of these things, and you can do it gradually. The second thing is kind of very obvious follow up of this is the containers. And containers is people would kind of usually think of containers as just like, oh, well, we put microservices, it's loose coupled, we put in containers, we're done. This is what containers are cool for. But containers are actually a bit more. I mean, the way I think about that is that it has this really cool features that, like what I say there in the fine print and below, is that it gives you predictability, and it gives you predictability of your builds, and it gives you a predictability of your deployment. So it kind of eliminates a few things. So it eliminates this works on my machine kind of thing. So you cannot anymore say that, um, oh, it doesn't work for you. Oh, cool. But I don't know what it is. It works on my machine. So this kind of thing is gone as long as we're on same-ish architecture, like hardware-wise, and we are on the same um, way of dealing with containers and everything, we should be able to achieve this predictability of both your build, so you'll be able to build the system over and over again and achieve actually the same images and same results, and also deployment. So you don't have to do this kind of thing that we used to do on old days, where we would have like long installation scripts or way of installing that. I mean, of course, you can manually create an image and put it in a container and put it on the cloud, but you should try to automate this part quite as much as possible. So, which brings us also to the third tip, or third main area, is that thing of automation. And automation is, it's all about like making as little error prone as possible, and making it as fun as possible for us as developers. So to develop new stuff and not doing this boring, mundane thing of, I don't know, installing new containers or running things or configuring some kind of ports or something like that. All of those things should be automated as much as possible using containers, using some other technologies and stuff like that. And also, well, you'll get a few other things, right? But with containers, you achieve all those things that were mentioned, plus the portability. So you avoid lock-in most of the cases, especially if you don't put very specific cloud-specific stuff into your containers. And with automation, in addition to that, you'll save time, because computers do all those boring things faster than us humans most of the time. And it will be also less error prone, and that means that there will be less errors. That also means that there will be less downtime, right? So will be less of those errors, as I managed to show them as 404 errors, but it can be whatever, right? 500 or anything else, um, or other 400 errors. It doesn't really matter, but the point is there will be less errors and stuff like that. Um, and and also less toil. So toil was mentioned in the definition of cloud native, right, from CNCF, and this is the thing. So less of this things that people don't like to do but just have to do, and usually those things would be the ones that have most errors, because well, you're not doing your A game, where you're not really super interested in doing that particular task. And I mean, deploying a application to a server might be fun, like once, twice, maybe 5 times, but not if you're doing it like continuously, I don't know, 20 times a day, every day. It's not that something that you want you want to automate that as much as possible. It might sound as an obvious thing, but I still see a lot of developers and customers and people that are, still going a little bit in this kind of old fashioned way of doing things, and just like, oh, well, I just automated this little thing, but this is was so small, tiny little thing, so I just kept it manual and we'll just do it because, I've done it so many times, it doesn't take me time. But then when you have to onboard someone new and to explain the solution to someone, it's not just saying, just run this command and wait for 5 seconds and we'll be up and running. You actually have to explain them very detailed what to do and write long lists. And usually that's a kind of a smell of possibly a bad practice. Possibly you need to automate a little bit here. And again, you don't need to do that all at the same time. You can do it actually gradually, tiny little piece by piece. Mm, Fourth thing is resilience. Resilience, we talked a little bit about that already. And it's like the way your application behaves under pressure. So it can be amount of users, but it can also be things like what happens if your application fails, um, if something within your application, one of microservices fails, or some other integration points that are outside of your control fail. So how do you control that? How do you react to that? And there's a lot of ways of doing that, right? There's a bunch of techniques. So I don't know, like exponential backcalls, retry, some other retry. Ways of retrying to get an answer to what you have, failovers. You have, there's a lot of techniques that you can and should think about for your application, and actually test for all those kind of things and make sure that your application would graciously kind of handle all those things. So here, as you can see, we have the agility and we have the reliability. So the check mark and this little arrows, if you go a few slides back, you'll see that's like 2 and 3 right here. Um, and the last thing that I would like to mention is the serverless. And serverless is, again, I kind of try to pick a concept or two on each slide that people usually and kind of often misunderstand in one way or another, and serverless is kind of one of them. So first of the thing that people used to misunderstand with it was that, oh, well, serverless means that there is no server. So obviously that's not correct, right? You have to run it on somewhere. Serverless means no or less, or well, as little as possible of configuration. But then the other thing is that people think is that is kind of the next thing, which is a bit more common still. I would possibly argue is that people think that, oh, well, to go serverless, I need to be on a cloud provider. Technically, well, it will be easier, maybe, yes, but you don't have to. So serverless, you can run things serverless on your own, like on-prem solutions and stuff like that, and it will give you a lot of the same benefits. So it will give you this thing of um, it will give you this thing of making your hardware available for other applications when that particular application is not in use or in less use than you were expecting it to be. So it will kind of automatically scale up and down. There is a few projects that you can use for this kind of stuff. You can have a look, for example, at Knative, which is really, really nice thing that where you can actually install it on even your machine or like on your on-prem servers and get the serverless beauty of that, right? So you will get this when there is a lot of pressure, it will scale up. When there is little pressure, it will scale down and free the resources for some other applications. In reality, you will end up saving money. So that's tiny little thing down there that's supposed to kind of be the bills, money bills, and yeah, that's the thing. So serverless does not have to be on a cloud, but it often is. And there are different ways of doing serverless. So you have like just cloud functions, you have just you have actually serverless applications, full blown applications and containers, and can be different things. But again, to achieve all that, you will probably need to think again about your architecture, think about the way you structure things in your application and the way you handle things, the way you talk to other things inside your application. So, for example, if you want to make it scalable, you probably need to think about how do I make those containers as little dependent on the context as possible, so I can spin up 100 of them or parallelize those jobs without sacrificing the data or sacrificing the kind of the way I store things and things like that, right? So serverless is the fifth thing that I wanted to talk about. So now we have loose coupling in one way or another. Hopefully, all the way to microservices, but you're good if you haven't achieved it all the way. You have containers, which is you know reproducibility and all this. Um, um, and um, and then you have automation, resilience, and serverless. So those are the five things that I wanted to share with you. And now I think we should see if there are any questions. And I mean, you're more than welcome to ask any questions or comments and stuff like that uh, online. But you can also, this is me on Twitter that you see on the screen. So you're more than welcome to ping me also online, both in like direct messages or open messages and anything. Anything on the chat, Anna?
No, nothing on the chat. So there are no questions. Everything that you shared is clear. Probably people are sharing the same opinions of you regarding the why, the how, and what.
Oh yeah,
Um,
that would be really fun to hear. I mean, we'll see. So I give you a challenge to all of you listening. Give me some feedback, and you're more than welcome to say I agree. That's fine, but you can also say I totally disagree on this, on that, and that, and let's have a chat. That would be fun. All right.
okay.
Yes, back to you.
So what I wanted to ask you, like, because I saw that you're talking also about vendor lock-in, and I think we have a couple of minutes more. I think like two more
Yeah, I
minutes.
think we have a few minutes. We have like at least 2 minutes
Two
according to the
minutes.
schedule.
Let me ask the questions, or let's have a nice chat
That's great.
regarding
Yeah.
cloud native, because this is a very beloved topic.
Mhm.
And the thing is that about vendor lock-in, because I've seen a lot of concern around this.
Mhm.
Um, and my opinion is like better to implement something and have something running and then think about like moving somewhere else. I think it's easier to move something that is running properly to some else if you're not happy with the place where you
Yes.
are, then just wait and be totally agnostic.
Fantastic point. Thank you very much for saying that. I mean, I couldn't have said it better because there's usually two things, right? The one thing is that what you said, people will just like wait by just like, oh, well, if we just wait, somehow we'll get this vision of how to make it cloud agnostic, which will never gonna happen, but they just kind of don't dare taking a decision. And so then you will end up with really really bad solutions and stuff like that. But then you have to think of way of like, if you want to go to the cloud, you can maybe just do it like lift and shift, and you just put it into VM and just move it, and then you make it better. But then what the second thing that I kind of want to mention is that it's a very good point to it is totally okay. And I mean, I have seen it many times. That's why I'm mentioning. It's like sometimes you see like, oh, well, we cannot use this solution, even though it's really, really good and really perfect for our, let's say, I don't know, data warehouse, like storing data, but we cannot use it because it's very vendor specific thing. And we would be like, no, this is not how it works. I mean, use it because it's actually compatible with other things. So you can actually, with tiny little bit of work, you can actually move it and it will not cost you as much. But creating something that is totally portable from day one will cost you very, very much to develop. And it will cost you even more to run because you don't really have any specific plans to move, do you? No, we don't, but it would be nice. And then, you need to kind of say, okay, fine, but how much money you will actually spend on doing it possibly portable and it will be it's a little bit of kind of things that I hear from time to time, so I kind of wanted to get it out of the way and say this is commonly misunderstood concept, and thank you for
Mm.
for mentioning it
Well,
again.
this is like an experience had because like being in both boats, if I can say so, like once
Hmm.
waiting and once just going with the flow. And I can say that going with the flow is way better,
Hmm.
and doing something and implementing something, and then you know just shifting to something better. It's way easier to shift to something better than just to wait and be agnostic. And it's also kind of frustrating sometimes, even for developers, like all the time, wait for that thing that's going to make you agnostic when you're going in an implementation. Yeah. Thank you very much, Rustam. Unfortunately, we're out of time. I would have wanted to spend a little more time with you, talk about cloud native. But again, thanks for joining us. The sun has come here down my way.
Thank you very
um,
much. It's sunny today here as well, surprisingly, but yes.
cool, cool,
Thank you
good
very
weather.
much for having me.
Thank
Have
you.
a
And
great day.
thank you.